Hello, my name is Isaac Omodia. I am a rising junior studying aerospace engineering at the University of Maryland Eastern Shore. In this video, I will be showcasing a BCD to 7 segment decoder that was made in Minecraft using redstone circuits. This video assumes that you, the viewer, have at least some basic knowledge about how redstone works in Minecraft and an understanding of K-maps. As you can tell from the name, a BCD to 7 segment decoder takes in binary coded decimals as an input and generates an appropriate output for the 7 segment display to show the digital input. That's n is 6. This is the truth table for a BCD to 7 segment decoder with a common cathode. The letters W, X, Y, and Z are the BCD inputs, with W representing the least significant bit and Z representing the most significant bit. Letters A through J represent the 7 segments of the 7 segment display. Using this truth table, K-maps are constructed for each output segment and then simplified to obtain a logic combination of inputs for each output. Using these simplified values, a combinational logic circuit was then created for each signal. Here we have the BCD inputs: W, X, Y, and Z. And we have the input lines running all the way to the end, with the leftmost line being Z, the most significant bit, and the rightmost line being W, the least significant bit. These lines are appropriately fed into these logic gates, the outputs of which are then fed into the appropriate segments of this 7 segment display. Okay, let's take a more detailed look at one of these segments. This is segment G. This is segment A. Okay, let's take a look at segment A. You can see that segment A's K-map simplifies to these equation: X plus Z plus W times Y times Z prime. And recall that plus represents the OR operation and times represents the AND operation. So here we have the line coming from it's X, right? WX. Yes, this is the line coming from the X input. So this is X, and this is a line coming from Z, and this is the 3 inputs AND gates with the inputs is W. This is W, the line from W, and this is the line from Z. No, this is the line from Y. This is Z prime. 3 of them come into these 3 inputs AND gates. These lines are connected to form an OR gate, the output of which is then sent to segment A at the top of the screen. That's the line going up there. It says, yeah, that's 7 segments A delay. Yeah. And the same goes for segment G, the gates, and the output goes to segment G. Here we have segment B, the gates, the inputs coming from the input lines, and the output goes to segment B. We also have the same for segment C, segment D, segment E, and segment F. So the lines going to the LCD. It's not an LCD, it's a 7-segment display. This is segment A, the line going to segment A all the way up here. Segment A. If I recall, this is segment D at the bottom, so that's A, B, C, D. This is the line coming from the output of segment D's logic gates, logic circuits. This is D, this is E, right? Yeah, this is E, and this is F that goes to the top there. Yeah. The screen itself, while it was a bit challenging, it's not a point of interest. It wasn't a point of interest in this project, but I would include a link to the video I referenced in making this video, in making this screen, in the description. So now just gonna play with this a little bit. We have 0, 0. Just in case you don't know, if this is a switch, if the switch is pointing up, that's a 0, like off. It's in its off state. If the switch is pointing down, it's a 1. It's in its on state, and you can see the redstone light up. And this is Z, the most significant bit, through W, the least significant bit. In this state, we have 4 switches at 0, 0, 0, 0, which is BCD for 0. In this design, when all the switches are off, the LCD screen turns off. Of course, in an actual 7-segment display, it would display 0, but I forgot to include 0. I was too far gone in the project. I decided to move ahead. Okay, but when we have 0, 0, 0, and 1, we should have a 1 display on the screen. So we have 0, 1, 0, 1, which is a 5. We should have a 5 display on the screen. Let's do, this is 7, right? Yeah, we should have a 7 display on the screen. Well, but we'll do 3. So we have 0, 0, 1, and 1. We have a 3 displayed on the screen. I had 8 here before, but turn these off. So that's a 0. Everything goes off. If you have a 1, 0, 0, 0, that's 8. That's BCD for 8. If you have 1, 0, 0, 1, that is 9. This design only goes from 1 till 9. Anything above 9 will give an error. Of course, I could design it to give a sensible answer, but I just decided to go from 1 till 9. It's given 8, but it's an error. It only goes from 1 to 9 reliably, because that's what it was designed to do. That is 9. Yeah, thank you.